because this colorless liquid, which is now water, does not contain dissolved salt. And therefore,
and today we are continuing with our discussion on the topic of nitrogen and its compounds, and we are going to look at an alternative method of preparing nitrogen 4 oxide. Previously, we saw that nitrogen 4 oxide is prepared by the action of concentrated nitric 5 acid on copper tannings. That is the method that we discussed previously. So today we are going to look at an alternative method, and this is through thermodecomposition of metal nitrates. Now, metal nitrates that are below sodium in the reactivity series, when they go through thermodecomposition, that means decomposition by use of heat, they break down in such a way that nitrogen 4 oxide is produced as one of the gases. And in our case here, we'll prefer using lead 2 nitrate. And the reason why we prefer using lead 2 nitrate is because it is not hydrated, or it doesn't contain the water of crystallization. So, alternative method of preparing nitrogen 4 oxide. So you can say that nitrogen 4 oxide can also be prepared by the action of heat on metal nitrates below sodium in the reactivity series. Below sodium in the reactivity series, preferably lead 2 nitrate, because it is not hydrated. It doesn't have the water of crystallization. So on this, we find that through thermodecomposition, when lead 2 nitrate in solid form is heated, this is what we are calling thermodecomposition. By the action of heat, we produce lead 2 oxide, which is a solid. We have nitrogen 4 oxide gas and oxygen gas. So that is the equation for the reaction. Lead 2 oxide, this is red, this is red brown when it is hot and yellow when it is cold. So to balance the equation, we have 2 nitrogen. So we can make this to be 2. The oxygen are 6. Here they are 4, 7. We can make them 8. And we make lead to be 2. That makes 6 times 2. We can make these ones to be 4. So that is lead is balanced, nitrogen they are 2 times 2, 4. Oxygen is 12, 2 plus 8, 10 plus, yeah. So the equation is balanced. as it is. So we're going to have a diagram to show how that preparation is done. So we are saying that lead 2 nitrate crystals are heated, and when they are heated, they go through thermal decomposition to produce nitrogen 4 oxide. The nitrogen 4 oxide is passed through ice salt mixture where the gas is condensed, and this is to obtain a liquid there, and that liquid is pale yellow liquid. And then of course the remaining gas, which is oxygen, is collected in a gas jar over water. So this is another way of a laboratory preparation of nitrogen 4 oxide. So basically we are saying that when lead 2 nitrate is heated, it decomposes to form lead 2 oxide, which is red brown when hot and yellow when cold. So this one remains in the boiling tube. And the nitrogen 4 oxide gas is condensed to form a pale yellow liquid that is collected in a U tube. So this is a U tube, a U-shaped tube that has been immersed in ice salt mixture to allow condensation of the gas. And this pale yellow liquid is called dinitrogen tetraoxide. We are going to see more of that. And then oxygen is collected over water, as shown there in the diagram. So that is an alternative method. So we are saying that nitrogen 4 oxide is condensed into a pale yellow liquid in the U tube called dinitrogen tetraoxide. Dinitrogen tetraoxide. Dinitrogen with the 2 oxygen, tetraoxide with the 2 nitrogen and 4 oxygen. So basically what happens, the equation here, then nitrogen 4 oxide gas on cooling, it changes into dinitrogen tetraoxide, and this is a reversible reaction. That is, on heating, the reverse takes place. So this is that. Nitrogen 4 oxide is red-brown. Dinitrogen tetraoxide is pale yellow. So we are saying pale yellow dinitrogen tetraoxide. So that is how the nitrogen 4 is collected. So it's collected by liquefaction. That method whereby the gas is collected in a U-tube by changing it into a liquid is called liquefaction. So basically, the oxygen, we know that it is slightly soluble in water, so it's collected as shown in the diagram. So this is an alternative method of preparing nitrogen 4 oxide. So let's say something about the properties. And these are the chemical properties. We have already looked at the physical. The chemical properties. And we can say that one, nitrogen 4 oxide dissolves in water to form an acidic solution. And this solution, which is a mixture of nitric 5 acid and nitric 3 acid. So when the gas dissolves in water, we form 2 acids. That is nitric 5 acid and nitric 3. Balancing is okay. Yep. So nitric 3 acid is oxidized by oxygen in the air. To form nitric 5 acid. So we can say that nitric 3 acid is not very stable. So after a short while, it changes into nitric 5 because of its exposure to the oxygen in the air, and it becomes oxidized. So we can see that HNO2 plus oxygen that is in the air, we form nitric 5. So that is as far as the acidity of nitrogen 4 oxide is concerned. We can also say that the gas supports combustion of strongly burning metals, e.g. magnesium plus nitrogen 4 oxide. So magnesium decomposes nitrogen 4 oxide into nitrogen and oxygen, and magnesium is oxidized to magnesium oxide, while nitrogen is separated. So there is decomposition of nitrogen 4 oxide into nitrogen and oxygen. The oxygen now oxidizes the magnesium to magnesium oxide. Then the nitrogen is left. So this is a reduction. And this is an oxidation. So we are going to stop there and have an assignment. So the assignment, question number 1, write a balanced chemical equation for the preparation of nitrogen 4 oxide from lead 2 nitrate crystals. 2, state 2 chemical properties of nitrogen 4 oxide. So we are going to stop there and continue next time. Goodbye.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi. Today we continue with our biology lesson, Form 1, and today we are going to discuss cell organization. When you talk of cell organization, this is how the cells are assembled together to form tissues, organs, and organ systems within the body of an organism. So this is how cells are assembled together to form tissues, organs, and organ systems in living organisms. So the first level of organization are the tissues. We have tissues, and a tissue is a group of cells performing a specific function. A group of cells performing a specific function make a tissue. So we'll have animal tissues, and in animal tissues we have blood, which consists of red blood cells, white blood cells, and platelets. All those are blood cells, or they are cells that make the tissue that we call blood. Another example of animal tissues, tissue, and this one is the one that connects various organs in the body. We have epithelial tissue. These are animal tissues. And this one is found at the inner lining of tubular body structures. The inner lining of tubular body structures, e.g., along the digestive system. Another example of the animal tissue, we can also talk of the muscles or the muscle tissue, made up of groups of cells that bring about movement. So basically, those four are examples of animal tissues. We have blood, connective tissue, epithelial tissue, and muscle tissue. So let's go through various examples of plant tissues, tissues that are found in plants. So plant tissues include, 1, epidermal tissue, and this is the tissue found at the outer surface of stem, root, leaf, etc. So this tissue is mainly for protection. It's mainly for protection. Against mechanical damage. Attack by microorganisms. etc. So basically, epidermal tissue is for protection. Then another plant tissue, we have the palisade tissue, and this is made of palisade cells that we learned earlier. And the palisade tissue has palisade cells with numerous chloroplasts for photosynthesis. So this tissue is found in the leaves, and it's the main area where photosynthesis occurs. There is the vascular tissue. This one is mainly for transport. For transport of water, mineral salts, and nutrients. So vascular tissue. We have another one. This one is called parenchyma tissue. This one is for storage of food and water. So basically those are some of the tissues we have in animals and also in plants, and they carry out different functions. In other topics, we'll, for example, discuss blood and other tissues in relation to animals. The same case applies to plants. So basically, for now, this is just to make you aware that they do exist and they carry out specific functions. The other level of organization after the tissue is the organ. The organ is the other level of organization. So we have organs, and we can say that organs are groups of tissues. That perform related functions. We have very many organs in our bodies, and all those organs are made of groups of tissues. For example, we have organs such as the heart. The heart is an organ. The kidney. So those ones are made of various tissues. Then, in plants also, we have organs such as the leaves, made of the plant tissues. We have things like the stem, made of various tissues, and so on and so forth. So the last level of organization is called the organ system. And these are groups of organs that are coordinated and synchronized together. Groups of organs that are coordinated and synchronized together to perform certain functions. Examples of an organ system is, e.g., the digestive system. So this is a system made of groups of organs. For example, in the digestive system, we have the stomach, we have the intestines, we have the esophagus, and so on and so forth. So that's an organ system. We have the excretory system, made of the kidney, the urinary bladder, and so on and so forth. So those ones are a group of organs. They form an organ system. But a group of tissues form an organ, like the heart, the kidney, and so on. A group of cells form tissues, either tissues in plants or tissues in animals, as we have seen. And we have seen that different tissues play different roles. So that marks the end of the topic of the cell. But before we finish, it is important to have a short assignment to remind us what we have learned. So the first question in the assignment, what is a tissue? We have discussed that. Number B, name 3 tissues in plants and their functions. Any 3 tissues in plants and their functions. Number 2A, what is an organ system? B, explain why the digestive system is an organ system. Why the digestive system is an organ system. So we'll stop there. That marks the end of the cell. We shall meet in other topics to come. Goodbye.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi. I welcome you to today's chemistry lesson. The topic of discussion is structure of the atom and the periodic table. So today we are going to discuss oxidation number. Oxidation number, this is the charge possessed by either an ion or a radical. Ions and radicals are charged particles. So the charge that they possess is referred to as the oxidation number. So for example, a copper 2 ion written as Cu2 positive has an oxidation number of positive 2. So that is the charge that it carries. Another example, a chloride ion, Cl negative, has an oxidation number of -1. So the charge that is indicated there. If you take an example of a radical, like a carbonate, CO3 2 negative, this one has an oxidation number of -2. So oxidation number is the charge that is possessed either by an ion or a radical. Atoms have an oxidation number of 0. Atoms have an oxidation number of 0. So they have no charge. And of course, we discussed that earlier in the topic, whereby we said that the reason why atoms have no charge is because the number of protons is always equal to the number of electrons. The number of positive charges is always equals to the number of negative charges. So in this case, the oxidation number is only found in ions and radicals. The other thing I want us to discuss is chemical formula. And the chemical formula represents compounds whose formula is written using the valences. So to write the correct chemical formula, it is important to understand the valency, which is the combining power of elements. And we'll take an example. We want to ask ourselves, what is the chemical formula of A, magnesium oxide? We leave a space for answering that. Then B, calcium chloride. So the first thing when you're writing the chemical formula, we write the symbol for magnesium is Mg, oxide is O. Then we come here and indicate the valency. The valency for magnesium is 2. The valency for oxygen is 2. So where they have the same valency, you simplify it into 1:1, and then you cross multiply. So the formula will be Mg multiplied by 1, O multiplied by 1. So that will be the chemical formula for magnesium oxide. So for calcium chloride, the symbol, so we start with the symbol, and then chloride is from chlorine. The valency is 2. The valency here is 1. So here you don't simplify, you just cross multiply. So calcium multiplied by 1 is calcium. Chlorine multiplied by 2 is Cl2. That's the valency for calcium chloride. So basically that's how we use the valencies to write the chemical formula. Can take a third example. One that is involving a radical. We want to write the formula for sodium carbonate. So sodium, the symbol is Na. Carbonate is CO3. Of course, 2 negative. The valency for sodium is 1. The carbonate, the valency is equivalent to the charge. It's equivalent to the oxidation number, which is 2. So you cross multiply. Sodium you multiply by 2. And then the carbonate you multiply by 1. So that will be the formula for sodium carbonate. So you will only use the charge to get the valency. So in the final answer, you don't put the charge. The charge has already been neutralized. So that's the formula. So we'll have an assignment on that. So in the assignment, what is the oxidation number? What is oxidation number? Number 2, determine the chemical formula of calcium nitrate, sodium hydroxide, potassium hydrogen carbonate, and magnesium sulfate using the valencies. So we'll stop there until next time. Goodbye.
Welcome to Manifested Publishers.
Wambaje mwanafunzi, karibu katika kipindi kingine cha Kiswahili hapa katika ukumbi wetu wa masomo ya mtandaoni Manifested. Basi leo nakukaribisha ili tuweze kusoma sarufi ya lugha ya Kiswahili, na kile ambacho tutaingilia zaidi ni ngeli. Nazo ngeli ni 2 kwa siku ya leo, ngeli ya na ngeli ya izi. Hiyo ndiyo kazi tutakayoifanya kwa siku ya leo. Hizi ngeli, nafikiri katika mazungumzo yako umetaja maneno ambayo yako katika hii ngeli, labda kwa kujua ama bila kujua. Basi kwa siku ya leo nataka tuzamie zaidi, tutungie sentensi katika umoja na katika wingi, na hivyo basi utaona jinsi kazi yenyewe ilivyo rahisi. Basi tuingie moja kwa moja, tushughulikie moja baada ya nyingine. Tuanze na hii ngeli ya yaya. Ngeli ya yaya tuanze nayo. Basi maneno katika hii ngeli huchukua kiambishi ya katika umoja na ya katika wingi. Maneno katika hii ngeli huchukua kiambishi ya katika umoja na ya katika wingi kama viambishi ngeli vyake. Hivyo basi nataka tuweze kufikiria baadhi ya maneno ambayo yanapatikana katika hii ngeli, tutunge sentensi katika umoja na katika wingi, tuone jinsi ambavyo hii ya itajitokeza katika umoja na hii ya ijitokeze katika wingi. Fikiria hayo maneno. Nina neno kama vile maziwa. Maziwa. Mfano katika sentensi utasema vipi? Maziwa yamemwagika ama yamemwagwa. Maziwa yamemwagwa. Hiyo ni katika umoja. Katika wingi itakuwa wingi wa maziwa yanabaki kuwa maziwa. Basi itakuwa maziwa yamemwagwa, na katika wingi iwe hivyo hivyo kwa sababu hakuna wingi. Maziwa yamemwagwa. Angalia hiyo sentensi. Katika umoja tuna kiambishi ngeli ya. Kiambishi cha ngeli katika umoja ni ya, na katika wingi ni ya. Maziwa yamemwagwa, angalia kiambishi ngeli, na hapa maziwa yamemwagwa. Mbali na maziwa, neno jingine katika hii ngeli ni neno maji. 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 Utasema vipi katika umoja hiyo sentensi? Maji yamefanya nini? Maji yamekauka, ama maji yamechafuliwa, ama maji yamechafuka. Maji yamechafuka. Maji yamechafuka, hiyo ni katika umoja, na katika wingi ibaki hivyo hivyo. Katika wingi ni maji yamechafuka. Hii ni katika umoja na hapa ni katika wingi. Nafikiri unaelewa kile ambacho kinaendelea. Unaona katika umoja kiambishi ngeli ni ya. Kiambishi ngeli ni ya. Katika wingi vivyo hivyo kiambishi ngeli ni hiyo ya. Tunga sentensi nyingine, tafuta maneno mengine katika hii ngeli. Neno manukato. Manukato. Manukato yalinukia. Yalinukia. Manukato yalinukia. Manukato yalinukia. Na hata katika wingi itabaki vivyo hivyo. Manukato yalinukia. Nataka uelewe zaidi kwamba kiambishi ngeli katika umoja hapa ni ya, na katika wingi ni ya. Kiambishi ngeli katika umoja ni ya, na katika wingi ni ya. Fikiria neno jingine kama vile neno maradhi. 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 Neno maradhi. Maradhi. Neno maradhi. Maradhi yameangamiza watu. Maradhi yameangamiza mtu. Maradhi yameangamiza watu. Basi katika umoja, maradhi yameangamiza mtu. Maradhi yameangamiza mtu. Maradhi yameangamiza mtu. Hiyo ni katika umoja, maradhi yameangamiza mtu, na pale katika wingi ni maradhi bado yameangamiza, sasa sio mtu sababu ni wingi, iwe watu. Maradhi yameangamiza watu. maradhi yameangamiza watu. Basi mwanafunzi, mtazamaji, msomi wa lugha ya Kiswahili, umepata kuelewa kwamba katika umoja kiambishi ngeli ni ya, na hivyo katika wingi kiambishi ngeli ni ya. Ndio maana tunasema haya maneno yote yako katika ngeli ya. Yako katika ngeli ya. Mifano ni mingi tu. Fikiria mingine kama vile mate. Fikiria marashi. Maneno ambayo yako katika hiyo ngeli ya. Basi wacha tuangalie ngeli ya pili ambayo ni ngeli ya izi. Ngeli ya izi. Tumeshakamilisha mambo ya ngeli ya yaya, na inamaanisha kwamba maneno ni mengi tu ambayo tunaweza kuwa nayo, lakini nataka pia wewe changia zaidi. Tafuta maneno ambayo yako katika hii ngeli na uweze kutungia sentensi. Na utakapotunga sentensi utaona kwamba viambishi ngeli vitakuwa ni ya katika umoja na ya bado katika wingi. Tuangalie ngeli ya izi. Ngeli ya izi. Ngeli ya izi. Katika hii ngeli ya izi kawaida tunasema kwamba maneno katika hii ngeli viambishi ngeli vyake huwa i katika umoja, na zi katika wingi. Huwa i katika umoja na zi katika wingi. Hebu fikiria maneno katika hiyo ngeli mengi tu, kama vile fikiria neno kama chupa, karatasi, nguo, ngoma, ndizi na kadhalika. Fikiria maneno yote hayo kisha uyatungie sentensi. Utakuja kuona kwamba katika umoja yanachukua kiambishi i na katika wingi kiambishi zi. Hebu angalia katika umoja, kwanza tutunge sentensi umoja, na hii sehemu iwe ya wingi. Hebu tuangalie neno kama vile sahani. Neno sahani liko katika hii ngeli ya izi. Hivyo basi tunga sentensi uone jinsi hivyo viambishi ngeli vinavyojidhihirisha. Sahani imenunuliwa. Sahani imenunuliwa. Moja. Lakini zikiwa nyingi sema kwamba sahani zimenunuliwa. Sahani zimenunuliwa. Sahani zimenunuliwa. Sahani zimenunuliwa. Angalia, sahani zimenunuliwa. Basi katika umoja tumeona kiambishi ngeli ni i, na katika wingi kiambishi ngeli ni zi. Hicho ndicho ambacho tuna haja nacho. Chukua neno jingine kama vile neno karatasi. Karatasi imeraruka. Karatasi imeraruka. Karatasi imeraruka, na zikiwa nyingi basi sio moja, karatasi imeraruka, lakini zikiwa nyingi ni kwamba karatasi zimeraruka. Karatasi zimeraruka. Kiambishi ngeli onesha vizuri. Kiambishi ngeli i katika umoja, kiambishi ngeli zi katika wingi. Tafuta neno jingine samahani. Neno kama vile nguo, nguo imechomwa. Nguo imenunuliwa. Nguo imeraruka na kadhalika. Sema chochote kuhusu nguo. Nguo imechomwa, labda. Nguo imechomwa. Nguo imechomwa, nguo imechomwa. Na basi katika wingi itakuwa ni nguo moja, 2, 3, 4, zitakuwa nguo nyingi, basi nguo zimechomwa. Nguo zimechomwa. Nguo imechomwa, na pale nguo zimechomwa, basi onyesha imechomwa na hapa zimechomwa. Hivyo nafikiri unaona jinsi ambavyo viambishi ngeli vinavyoonekana kwa uwazi. Chukua neno jingine kama vile neno chupa. Neno la mwisho sasa, neno chupa, chupa, chupa. Neno chupa, chupa. Unaweza ukasema nini kuhusu chupa? Chupa moja. Chupa moja unasema kwamba labda chupa imejaa. Chupa imejaa, ama chupa ilijaa. Ilijaa. Chupa ilijaa. Zikiwa nyingi basi zilijaa. Chupa zilijaa. Hebu angalia sentensi. Chupa ilijaa na hapa chupa zilijaa. Kitu ambacho nina haja nacho ni uone viambishi ngeli katika umoja na katika wingi. Unaona hapa ni z. Katika hii nyingine z. Katika hii nyingine karatasi karatasi z. Sahani sahani z. Basi nomino katika hii ngeli zinachukua kiambishi ngeli katika umoja na z katika wingi, hasa katika vitenzi vyake. Hivyo ndivyo viambishi ngeli katika ngeli hizi mbili. Tumeanza na ngeli ya yaya, tukaona ni ya katika umoja na ya katika wingi. Pale ni katika umoja, z katika wingi. Basi kwa sababu mimi ndiye ambaye nimekuwa nikizungumza, basi nataka niamini kwamba hapo ulipo pia ulikuwa ukiandika mifano ya sentensi ili uweze kuelewa kile ambacho tulikuwa tunasoma kwa siku ya leo. Basi nikupe kazi kidogo ambayo nataka pia wewe uifanye. Kazi mradi, ushughulike pia wewe. Zoezi lako. Mwanafunzi, kazi yako ndio hiyo, nyepesi zaidi. Andika wingi wa hizi sentensi. Ona, ndizi imeiva ikiwa moja, andika wingi. Dawa imenunuliwa. Zaidi, ndoo ilitoboka. Hapa pengine malipo yalipokelewa. Nambari ya 5, makao yamepatikana. Na mwisho, marashi yamemwagika. Hadi hapo hakikisha kwamba kazi yenyewe umeifanya. Usije ukazembea. Kumbuka kwamba ajizi nyumba ya njaa. Usije ukajaribu kuzembea. Hakikisha kwamba umefanya kazi hiyo kabla ya kupatana nami katika ile video nyingine inayokuja. Shukran, siku njema.
Welcome to Manifested Publishers.
Hello, my dear learner. Welcome back to Manifested e-learning platform. I am Teacher Purity, and we are going to learn English activities grade 3. So we are still discussing grammar, and under grammar, we are talking about the use of has. The use of has. Remember, we had already introduced ourselves to the use of has during our previous lesson. So make sure, in case you missed a point in the last lesson, you are paying attention. So the use of has. We say that has is used before or alongside pronouns she, he, it, and who. Has is used alongside pronouns he, she, who, and it. So has is used alongside he, she, he, who, and it. Has is used alongside he, she, who, and it. He when you want to introduce a male person, she when you want to talk about a female, who it's used in a question, and it when you want to talk about things that are one of a kind. So has is used alongside he, she, who, and it, and therefore it is used in singular form. Has is used in singular form. It is used in singular form. It is used in singular form. And it can also be used when you want to introduce or when you want to talk about singular nouns. Singular nouns, it might be a name of a person, or you are just saying the real name of that person. So has can be used when introducing a singular noun. It is also used after singular nouns. After singular nouns. And therefore has is used in present tense. It is used in present tense. It is used in present tense. Now let's get to know more examples of how we can use has in a sentence. Examples. Example 1. He has a pet. He has a pet. So this sentence is talking about a person who has a pet. Then she has a new doll. She has a new doll. Remember that remember that has comes after the pronoun, or it comes after the first bit of the sentence. It cannot start a sentence. It comes the second. Then who has washed the utensils? Who has washed the utensils? It is a question, and therefore has will come after the word who. Remember, we also say that has is also used after singular nouns. After singular nouns, you can mention the name of those particular people. For example, if you are called Kimani, you can say Kimani has a book. Kimani has a book. So another example. Kimani has a book. Kimani has a book. Kimani is one person, and therefore we shall use has after the noun Kimani. Another one can have a sentence. Njogu. Njogu has a new car. Njogu has a new car. So these are just examples of sentences where we can use has. How we can use has. Remember that it is used alongside he, she, who, and it. And mostly has is used in singular form. And it can also be used after singular nouns. And singular nouns are names of people. So I want us to go through or review the exercise that I gave you together. And later I will add you more work on the use of has. So the questions are here. The instructions were write has, in the blank spaces provided. Write has in the blank spaces provided. I will write the questions. Question 1. She dash a new dress. Question 2. The sun dash shining. Number 3. He dash a new watch. Then, who dash my storybook? Who dash seen my storybook? The new girl dash a nice name. That's the last question. So, these are the questions, number 1 up to number 5. The instructions were very clear. Write has in the blank spaces provided. You are only required to fill in the blank spaces with has. But before you answer any question, it is always good for you to read through the questions first without the answers. Then you now answer the question. So, sentence 1, she dash a new dress. Number 2, the sun dash been shining. Number 3, he dash a new watch. Question 4, who dash seen my storybook? Who dash seen my storybook? Number 5, the new girl dash a nice name. The new girl dash a nice name. So let's start answering the questions from the first one. She dash a new dress. She dash a new dress. Fill the blank space with has. Then after filling in your answer, you are supposed to read the whole sentence. She has a new dress. She has a new dress. If your answer is the same as what I have on the board, give yourself a mark. Question 2, the sun dash been shining. The sun dash been shining. Write your answer has in the blank space and read the sentence. The sun has been shining. The sun has been shining. So give yourself a mark. Number 3, he dash a new watch. He dash a new watch. So he has a new watch. He has a new watch. Make sure that you are confirming your answers from what you have on the board. If you have the correct answer, give yourself a tick. And in case you didn't fill correctly, just write the correct answer at the top of the blank space that you had been given. Number 4, who dash seen my storybook? Who dash seen my storybook? So fill in the blank space. Who has seen my storybook? Who has seen my storybook? Number 5, the new girl dash a nice name. The new girl dash a nice name. So the new girl has a nice name. The new girl has a nice name. So that's all you're supposed to do, to fill in the blank spaces with has, and also read through your work. So if you have everything scored correctly, that is very good work. And in case you didn't get right, make sure that you are doing corrections. I'm going to give you more work on the use of has. So let's copy the work. So I've added you more exercise on the use of has. 5 questions from number 1 up to 5. The instructions: use has to fill in the gaps. Use has to fill in the gaps. Remember the rule: read the questions first before you answer them. Then after answering them, you read the whole sentences. Now question 1, Pat dash a new uniform. Pat dash a new uniform. Number 2, the girl dash a big lunchbox. The girl dash a big lunchbox. Number 3, my father dash a car. My father dash a car. Number 4, Tom dash a puppy. Tom dash a puppy. And lastly, it dash been raining heavily. It dash been raining heavily. So finish the work and let's meet again in the next lesson. We shall learn something different from what we have discussed today. Thank you for being attentive.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi. Today we continue with our biology lesson Form 1, and we are looking at the cell structures and their function. During the last lesson, we discussed the structure of the cell membrane, the cell wall, and the cytoplasm. We also discussed their functions, and today we shall continue with the same, whereby we shall look at other organelles that are found within the cell, and of course we shall look at their functions as well. So the next organelle that I want us to look at is the mitochondria. Mitochondria is plural when there are many. When it is one, it's called mitochondrion. Mitochondrion is the singular. So when it is one, it is a mitochondrion. When there are many, they are referred to as the mitochondria. It is important to note that because you can be penalized if a question is asked in singular and then you answer it in plural. So you're supposed to answer a question that is asked in singular, answer it in singular, and one that is asked in plural, answer it in plural. Now, I would want us to have a diagram of a mitochondrion. So a mitochondrion looks like that. It's sausage shaped. It has a double membrane. So there is the outer membrane, and then there is the inner membrane, and this inner membrane is folded into structures known as cristae. These foldings, they are referred to as cristae. Then inside there is a fluid that we refer to as the matrix, and we shall look at the functions of each one of them. So this is a mitochondrion. So as I've said, when it is one, it's called mitochondrion. When there are many, they are referred to as the mitochondria. Now, so a mitochondrion, as we can see from the diagram, is a sausage-shaped organelle consisting of a double membrane. Consisting of a double membrane. The inner membrane, as we can see from the diagram, is folded into projections called cristae or cristae. When it is one, it's called a crista. And the cristae provide a large surface area, for the attachment of respiratory enzymes. So the cristae, then the matrix is a fluid medium in which respiratory activities take place. So basically that is a description of the structure of a mitochondrion. Let's look at its function. Its function we have mentioned as we were discussing the other parts. Basically, the mitochondrion is the site for respiration. So the function is that the mitochondrion, it is the site for respiration. So respiration occurs within the mitochondrion. It's also good to note that we have some cells that have more mitochondria than others. Some cells have numerous mitochondria, and that is because of the work that they do. If, for example, a cell is very active, it needs a lot of energy, and that energy can only come from the mitochondrion, which is the site for respiration, site for energy production. In fact, we call the mitochondrion the cell powerhouse. The cell powerhouse is where the power is generated from within the cell. So you can say that some cells in living organisms contain numerous mitochondria. Numerous mitochondria, and these include, among the cells that have numerous mitochondria, we have the muscle cells, sperm cells, kidney cells, and etc. And that is because those particular cells, even the nerve cells, and that is because those particular cells, they require a lot of energy. They require a lot of energy because of their high level of activity. The next organelle that we are going to discuss are the Golgi apparatus or the Golgi bodies. And according to their structure, these ones are stacks of membranes. The Golgi apparatus are stacks of membrane bound organelles. So they look like this. So they are stacks of membrane packed on top of each other. Placed on top of each other. It's also important to understand their functions. So the fact that they are membranes and they are elongated tells us that they are for transportation. So they transport a number of things. Number one, they transport synthesized proteins and carbohydrates. They transport synthesized enzymes. They are also responsible for packaging and transport of glycoproteins and also the formation of lysosomes. So all those are functions of the Golgi apparatus. So they have many functions, or they have several functions. Next, we discuss endoplasmic reticulum. And these ones are tubular and interconnected. Tubular and interconnected membranes with a cistern or with a hollow part inside. So just to have a view of how they look like. So they have the hollow part that is known as the cistern. They have the cistern. So this is an example of a smooth endoplasmic reticulum. So the function so they are also for transport. That's why they are tubular, they are tube-like. So smooth endoplasmic reticulum transport lipids, that is fats and oils. On the other hand, we have the rough endoplasmic reticulum, and the only difference is that rough ones contain some structures that we refer to as the ribosomes. So the rough one, it's more or less similar. Except that it has some granules on the surface. So those granules are what we are referring to as the ribosomes. And this is what we are calling the rough endoplasmic reticulum. So it's called rough because it contains the ribosomes. It contains the ribosomes that make it have a rough surface. Ribosomes are granules, and these granules we'll see what they are for just in a minute. So first of all, the function of the rough endoplasmic reticulum, reticulum transport proteins. They transport proteins. And of course, those proteins come from the ribosomes. The proteins come from the ribosomes. So finally, we talk about the ribosomes. And these ones are granules on the surface of rough endoplasmic reticulum. The function, they are sites for protein. So they are the sites in which proteins are synthesized. So basically, we've discussed the mitochondria, the Golgi apparatus, the endoplasmic reticulum, and the ribosomes, and of course their functions. So just to clarify something here, the rough endoplasmic reticulum are called rough because on their surface they have the ribosomes, which are some granules that act as the site for protein synthesis. And that is why the rough endoplasmic reticulum, its work is to transport the proteins that have been synthesized by the ribosomes. The smooth endoplasmic reticulum lacks the ribosomes, has no ribosomes. So it is smooth on its surface. So its work is to transport lipids, and lipids are fats and oils. So our assignment for today, so the first question, name 3 cells that have numerous mitochondria. We have mentioned them. Number 2, state 4 functions of Golgi apparatus. So we'll stop there for today. Until next time, goodbye.
Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson, which we are going to learn about molarity. But before I get into this lesson, I first have to remind you what we did in the previous lesson, which we were learning about concentration of a solution. And we said that concentration refers to the amount of a solute in a given amount of a solution. Amount of a solute in a given amount of a solution. For example, if maybe you take 10 grams of sodium carbonate in, let's say, 600 centimeters cubed of distilled water. 10 grams of sodium carbonate in 600 centimeters cubed of distilled water. Therefore, now concentration, since that concentration is now 10 grams per 600 centimeters cubed of distilled water. But now for uniformity purposes, to now ensure we see that this volume should be converted to, the volume should be converted to 1 liter. And therefore, if 10 grams are dissolved in 600 centimeters cubed, how many grams should be dissolved in 1000 centimeters cubed? Or how many grams can dissolve in 1000 centimeters cubed? And therefore, it is 1000 times 10 divided by 600. And then from there, we are going to get the concentration. And the concentration will be concentration will be 16.6667 grams per liter. Grams per liter, or 1000 centimeters cubed. That is what we were doing in the previous lesson. And again, we said that concentration can be expressed either as grams per liter or moles per liter. Grams per liter or moles per liter. Therefore, in this lesson, we are now going to focus on the molarity. And I will start by defining what molarity is. And we see that molarity is the number of moles per liter of a solution. Number of moles per liter of a solution. Number of moles per liter of a solution. The number of moles which are contained in 1 liter of a solution. That is what molarity is. Then it is expressed in moles per dm cubed, or just molar. Molar, and it is capital M. It is expressed in mole per dm cubed or molar. That is how molarity is expressed. I want us to do some examples on the same, and I will do one. That is one example. The question is, determine the molarity of a solution containing 10 grams of sodium hydroxide dissolved in 250 centimeters cubed of distilled water. I want us now to do it together. In this question, we have now first of all to calculate the number of moles of sodium hydroxide. And before that, we have now to calculate the RFM of sodium hydroxide. And the RFM of sodium hydroxide is 23. That is now the mass of sodium. Then you add the mass of oxygen, which is 16. Then you add the mass of hydrogen, which is 1. And this is now going to give you 40. Then we calculate now the number of moles. The number of moles are given by mass divided by the molar mass. Therefore, this will be mass is now 10 grams, which is 10 divided by 40, which is the molar mass. And this is now going to give you 0.4. 0.25. moles. Those are now the number of moles of sodium hydroxide. The number of moles of sodium hydroxide are 0.25 moles. Therefore, to determine the molarity of this solution, then we'll just say 0.25 moles. These are contained in 250 centimeters cubed. Yes, yourself, what about 1,000? Because molarity, they are contained in 1 liter. What about 1,000 centimeters cubed? It will be 1,000 times 0.25. We divide by 250. You'll get this as 1. This is 1 mole per dm, 1 mole per dm cubed, which can also be written as 1 molar. That is the concentration of this solution. it's now 1 mole per dm cubed, or 1 mole per decimeter cubed, or 1 molar. That is the concentration of 1 gram or 10 grams of sodium hydroxide dissolved in 250 centimeters cubed of distilled water. That is our first example. I want us now to do the second, and the second will be determine the concentration of a solution containing 20 grams of sodium nitrate dissolved in 500 centimeters cubed of distilled water. I want us to go through that question and see how we can be able to answer that question. We have first to determine the relative formula mass of sodium nitrate, which is given by the mass of sodium is 23 plus the mass of nitrogen is 14 plus the mass of oxygen is 16, but there are 3 atoms, then 16 times 3. Then this is 23 plus 14 plus 48, which gives us 85. The relative formula mass of sodium nitrate is 85. Therefore, we now start by getting the number of moles. These are now the number of moles of sodium nitrate, and the number of moles are given by mass, which is 20 grams, divided by the molar mass, which is 85. So it will be 20 grams divided by the molar mass, which is 85. And this will give you is 20 divided by 85, gives us 0.2 353 mole. 0.2353 mole. That is the number of moles of sodium nitrate, which were dissolved in 500 centimeters cubed of distilled water. 0.2353 moles are the moles of sodium nitrate, which were dissolved in 500 centimeters cubed of distilled water. Therefore, now to calculate the molarity, we just need to ask ourselves if 0.2353 moles are contained in 500 centimeters cubed, then how many moles will be in 1000 centimeters cubed? Then this will be 1000, just cross multiply 1000 times 0.2353, you divide by 500, and this will be this will be 0.4706 mole per dm cubed, which can also be written as 0.4706 molar. Just capital M will be enough to show molarity. Therefore, that is how we are going about the questions. One, to calculate the molarity, we are saying that you need to first get the number of moles. When you get the number of moles, then you can now be able to equate. If these moles are in this volume, then now what about 1,000? Because molarity, it is the number of moles which are contained in 1 liter. It must be 1 liter. Therefore, number of moles contained in 1 liter of a solution, that is what molarity is. Then I hope now I have given you a good insight. Therefore, I want to leave you with some questions which you are going to do. Then in the next lesson, we are going to do some of them. That is the assignment. 1. Determine the molarity of a solution containing 10.6 grams of sodium carbonate dissolved in A, 250 centimeters cubed of distilled water, and B, 500 centimeters cubed of distilled water. The second question, when 34.8 grams of potassium sulfate were dissolved in 500 centimeters cubed distilled water, calculate the concentration of potassium sulfate in grams per liter, and 2, the molarity of the solution. That I've given you the relative atomic masses of potassium as 39, sulfur as 32, oxygen as 16. Therefore, ensure that you've done those 2 questions before we meet in the next lesson. And in the next lesson, we are going to revise the 2 questions, and I will give you more questions in the next lesson. Therefore, let's meet in the next lesson.
Welcome to Manifested Publishers.
Welcome learners, my name is Stephen Kariungi, and today we are going to discuss a Form 4 topic in chemistry, and this topic is reaction rates and reversible reactions. So the topic is reaction rates and reversible reactions as indicated here. Before we get into the details about the topic, it is important to first of all understand what is the learner required to understand by the end of this particular chapter. So we shall first of all go through the objectives of this particular chapter. Chapter objectives. First of all, we should be able to define what is the rate of reaction. We should be able to define what is the rate of reaction, as the topic suggests reaction rates. So we should be able to define the rate of reaction and also explain a concept that is referred to as activation energy. So define the rate of reaction and also explain activation energy. So that's one of our objectives. Number 2, we should be able to describe some of the methods that can be used to measure the rate of a reaction. So to describe methods that can be used to measure the rate of reaction. Then number 3, we should be able to explain some of the factors that determine the rate of reaction. Explain some of the factors that affect the rate of reaction. After having done that, we should be able to draw graphs and interpret data from those graphs, targeting at measuring the rates of reaction. So we should be able to draw graphs and interpret data from those graphs. The data that is pertaining to measuring the rate of reaction. Then number 5, we should be able to explain now the second part of the topic, reversible reactions, simple reversible reactions. And lastly, number 6, we should be able to explain the concept of equilibrium. The concept of equilibrium and factors that affect the equilibrium. So basically those are the objectives that we need to fulfill by the end of this chapter. So we are saying that we should be able to define the rate of reaction and explain the term activation energy. Number 2, we should be able to describe methods that can be used to measure the rate of reaction. Number 3, explain some of the factors. Explain some of the factors that affect the rate of reaction. Then we draw graphs and interpret data pertaining to measuring the rate of reaction. Explain simple reversible reactions, and also the concept of equilibrium, and also the factors that affect the equilibrium. So having done that, now we'll start on the topic. So we're going to look at the concept reaction. And to start us off, we can say that the rate of a reaction simply refers to the speed at which a reaction occurs. For example, we know that there are some reactions that we carry out and then we get the results immediately. For example, during precipitation, if you have, for example, sodium sulfate and barium nitrate, and then you combine the two solutions together, you will get a precipitate immediately. So that's a reaction that occurs very fast. So you can say that the rate of reaction is high. On the other hand, we have an example of a reaction like rusting of iron. It's a reaction that takes a number of days before that reaction can take place. So you're saying that we have different reactions that take place at different rates. So you can say that some reactions occur immediately, e.g. precipitation of barium sulfate after combining sodium sulfate and barium nitrate. So that's a reaction that occurs immediately. Maybe you can write the equation. Sodium sulfate solution plus barium nitrate, also a solution. So the two will precipitate from barium sulfate, which is a white precipitate, and sodium nitrate, which is a solution. So we are saying that that's a reaction that occurs very fast, white precipitate. On the other hand, we can give another example. On the other hand, the rusting of iron takes several days. So that is a slower reaction. So we can therefore say that the rate of reaction, therefore, is the rate at which reactants are consumed. Reactants are consumed or used, or products are formed in a reaction. Is a measure of how fast or how slow are the reactants getting used, or are the products being formed. So because you know that in a reaction we utilize the reactants and then we form the products. So basically we are talking about the speed of a reaction. The speed of a reaction. And to determine the speed of a reaction, possibly we can measure the change in mass. Some of the properties that we look out for: change in mass, maybe change in volume if there's a gas that is being produced, and so on and so forth. So we are saying that some of the properties assessed include the change in mass. How is the mass changing? The volume of gas produced. You can also measure the intensity of color change, intensity of color change, etc. So those are some of the properties assessed during the determination of the rate of reaction, when we are determining whether a reaction is happening faster or slower. Then there is another concept that we'll introduce, as we have seen it in the first objective, and this is the concept of activation energy, that is abbreviated as EA. And we say that this is the minimum amount of energy that we need to overcome so that a reaction can take place. So we can say that this is the minimum amount of energy required for a reaction to take place. Or in other words, we can say that this is the barrier to a chemical reaction. So we must overcome that barrier so that the chemical reaction can take place. So we can have a short assignment on that. So in the assignment, there are 3 questions. What is the rate of a reaction? Number 2, name some of the changes that are used to determine the rate of a reaction. Then what is activation energy? So basically, that is what we have learned in our today's lesson. We'll continue from there.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi, and we continue with our topic of discussion in Form 4 Chemistry, and the topic is reaction rates and reversible reactions. In the previous lesson, we explained the collision theory and activation energy, and we said that a reaction takes place as a result of effective collisions between the reacting particles. So if there are no effective collisions between the reacting particles, then a reaction cannot take place. Then we said that the minimum amount of energy that is required to have or to cause effective collisions is referred to as activation energy. And we showed how that activation energy can be represented in a graph, for instance. Then we also discussed some of the factors affecting the rate of reaction, and today we shall explore on those factors, starting with concentration. So number 1, concentration, and we'll demonstrate this in form of an experiment to investigate the effect of change in concentration of sulfuric 6 acid on the rate of reaction. So the example that we shall have here is that we'll investigate the effect of change in concentration of sulfuric acid on the rate of reaction. And number 1, or the procedure, we'll first of all measure about, let's say exact, measure 40 cubic centimeters of 2 molar sulfuric 6 acid and transfer it into a conical flask. Step number 2, we also measure 30, then 20, and 10 of 2 molar sulfuric 6 acid and transfer each volume of the ones that we've listed into its own conical flask. Into its own conical flask. So we have 4 flasks. The first one has 40 cubic centimeters of 2 molar sulfuric 6 acid. The second flask has 30 cubic centimeters. The third has 20, and the last one has 10. So each of the flasks have different volumes of 2 molar sulfuric 6 acid. Then see, to the first flask, add 2 centimeters of a clean magnesium ribbon and immediately start a stopwatch. So you put 2 centimeters of a clean magnesium ribbon into the first flask, the one that has 40, and then immediately you start a stopwatch. And then measure and record the time taken for the magnesium ribbon to disappear. So the magnesium ribbon will react with the sulfuric acid until it disappears. So we measure the time taken for the magnesium ribbon to disappear. And then repeat the same with the other flasks. While making sure you add 10 cubic centimeters, 20 cubic centimeters, and 30 cubic centimeters of distilled water . So we are repeating the step number C, whereby for the flask that we had put 30 cubic centimeters of the acid, we top it up with 10 cubic centimeters of distilled water so that the total volume is 40, like the first one. For the flask with the 20 cubic centimeters of sulfuric acid, we'll add 20 of distilled water so that the total volume is 40. And the last flask with the 10 of acid, we shall add 30 of the distilled water so that the total volume again is 40. And then after that, we'll add the same size of magnesium ribbon and determine the time taken for the magnesium to disappear in each case. And then we record the results in the table below. So we'll have the flask, then we'll have the volume of acid added, then the volume of distilled water that was added, the concentration of the acid and then lastly the time taken in seconds for the magnesium to disappear. So in this table, we have flasks. We can number them as A, B, C, and D. There were 4 of them. A, we added 40 cubic centimeters of the acid. B, we added 30, or we put 30. C, we put 20. And D, we put 10 of the acid. Remember, we are adding the same size of the magnesium ribbon. That is 2 centimeters to each. And that magnesium ribbon should be clean to remove the oxide coating that may be on the surface. Then the first flask, we didn't add any distilled water because the total volume was already 40. We are adding distilled water to top up the volume to 40. So the one that had 30, we added 10. The one that had 20, we added 20. And the one with 10, we added 30 to make the total volume to 30. Then the question I would want us to ask ourselves is to determine, 1, the concentration of the acid in each flask, and 2, the time taken in each flask. So the first flask of 40, we used 2 moles per dm cubed of sulfuric acid. The second one, we used 30 cubic centimeters, so we reduced the volume from 40 to 30. So the concentration lowered from 2 to 1.5 moles per dm cubed. Then 20, we used the half volume of 40. So the molarity was 1 mole per dm cubed. And the 10 was a half of 20. So this one was 0.5 moles per dm cubed. So you can see that we are lowering the concentration in each of the flask by 0.5 by 0.5 by 0.5. So we expect that the time taken in A will be the shortest. This one will take the shortest time, and D will take the longest time. So basically we are saying that A is taking the shortest time, or is the fastest reaction, shortest time or is the fastest because it's where the concentration of the acid is the highest. And D is taking the longest time for the magnesium to disappear, so it is the slowest. And of course, we have the other. So we don't have the exact time here because we have not done the experiment practically. But basically what we are saying is that from these sample results, we know that A will take the shortest time because that's where we have the highest concentration of the particles, and therefore there will be more collisions there. There will be more collisions in A and the least collisions in D. So we'll have an assignment on that. So the first question, write a balanced chemical equation for the reaction between magnesium and dilute sulfuric acid that is taking place in this experiment. 2, explain how the concentration affects the rate of reaction. And then 3, sketch a graph of rate of reaction against concentration. So we'll stop there until the next time. Goodbye.
Welcome to Manifested Publishers.
How do you do? I'm glad to welcome you to another lesson. My name is Wilson Mwangu. In the previous lesson, we learned about something known as present participle, and we said it's about using a verb in the ing form. For example, the verb swim, we say swimming. The word eat, we say eating. So whenever we have a verb in its ing form, we call that the present participle. In today's lesson, we're going to learn how to write letters. And the topic is letter writing. Writing a letter to a friend. So that will be the lesson objective. So by the end of this lesson, I want you to be able to write a letter to your friend. Now I have to tell you this. We have two types of letters. There's what we call a formal letter and a friendly letter. So we can say this. There are two types of letters. One, formal or business. One is called a formal business letter, and number 2 is called a friendly or an informal letter. For today's lesson, this being standard 5, we shall focus on a friendly letter. As for now, let us forget about business letter. We shall do that at a later date, maybe in standard 6, not in standard 5. So let us look at a friendly or informal letter. When you write a letter to your friend, we call that a friendly letter. Now this letter is written to either a friend or a relative. So we say this, a letter written to either a friend or a relative. When you write a letter to your friend or to a relative, we call that a friendly letter. Now I want to remind you of a passage entitled Ukesho Helps a Grandmother.
And you saw in that passage that Wakesho took care of her grandmother for 3 days. Now I want you to imagine that after those 3 days, Wakesho writes a letter to her friend telling her or him how she took care of her grandmother. That's a letter to a friend. Or maybe you yourself, you did something, you helped somebody, so you want to tell your friend about what you did. You're going to write a letter to your friend, okay? Or even maybe your friend went to another school, transferred to another school. So you write him or her a letter asking him or her how the school is. That's a letter to your friend. So I want us to imagine of those various scenarios that will make you write a letter to your friend. That's called a friendly letter. So I want us to look at the format of a friendly letter. What is contained in that letter? So the letter will have the following. So we call this format or parts of a friendly letter. Number one, you must have an address. An address of you, the sender. Okay? Sender's address. Sender's address. Why should you have an address? So that the receiver of your letter can reply, right? Can write back. That's why you have to put your address there. I'll give an example. We shall look at that. So you must have an address. Number two, you'll have what to call salutation. Salutation. This whereby you're going to greet your friend, dear friend, okay? We call that salutation. We also have now the body. Now the main part of the letter, it will have greetings. Yes, you must greet someone. Purpose of the letter. Why are you writing that letter? Okay. Then best wishes. Best wishes. And then the last part is the ending of the letter. The ending of the letter. So these are the major sections of a friendly letter. One, as I said, it will have an address of you, the sender. It will have a salutation. It will have a body, and the body will have greetings, the first paragraph, the purpose, then the best wishes in the last paragraph. Then it will have an ending. All right? So I want to show you an example of, I've shown you the parts now, the format of that letter, how to write that letter. And I'm going to use this part here to show you how we're going to write that letter. So you're going to write your address here, the sender's address. Okay? For example, you go to this school called Warebu Primary School. Maybe the name of your school is called Mashiri Primary School. Let me just write again. Mashiri Primary School. You put a comma. P.O. Box. P.O. Box. (425) where? Nakuru. What is P.O. Box in full? PO box is post office box. Post office box. Now, every letter is normally sent through a post office, all right? And each post office has a number. It has a unique box. This would be the number. Your school has been assigned a box at the post office, and that box has its own unique number, all right? So you write the number here, okay? Yes, that's why you have the PO box, post office box. Each post office has a number, and there are so many boxes. Maybe you have seen when you go some near the post office, you're going to see so many boxes. So each school has been given a key and its own box, all right? So each box has a number. So the number is normally indicated there. So PO Box 425 Nakuru, the place where the box is found. So after this, now this is the address of the sender. Now you skip one line and write the date of the letter when you're writing the letter, okay? For example, you're writing this letter on 22nd. You can just write 22/04/2020. Yes. You're writing the letter on the 22nd of April 2020. But I've said you skip a line. And look at my date. My date, if I can use this ruler, when you are writing the address, you make what you call a slant. I hope you can see a slant. Slant. Okay? Then the date should be at the same line with the first, should be on the same line with the first letter. Should be on the same line with the first letter, that's the date. But the other part should be slant. So once you write the date, you skip a line, okay? This is the address of the receiver, whom we call the recipient. You skip a line, you come to this other side, left-hand side, where you write the salutation now that I talked about. For example, your friend is called Jane. Dear Jane. And before then you skip a line. Dear Jane. Then you put a comma. Okay? We call this salutation. Now after this, you begin writing your letter. And the first thing that I said, you send greetings. No, this is your friend. Jane is your friend, okay? You have missed her. So the first thing you're going to do is to send her greetings, right? So, dear Jane. So you write, how are you? You're going to leave some space here, what you call a margin. How are you? My dear friend. So once you have the first sentence, you can add something like that. Something like, receive my warm greetings, hoping that you are doing fine. Hoping that you are doing fine. Okay. So you can have another statement like, my classmates and I have missed you a great deal since you transferred to your new school, right? So this can be your first paragraph. Your first paragraph. Now, the second paragraph, you state the purpose of writing that letter. You have exchanged greetings. Why are you writing this letter to your friend Jane? You want to tell about, you did someone, remember the story of Wakesho? Wakesho helped her grandmother when she was unwell. You too helped someone when that person was unwell. So you're telling your friend Jane how you helped someone. Okay? So I want you now to complete this letter. But in the letter, you're going to tell your friend Jane how you helped someone who was feeling unwell. Someone who was unwell. All right? I'm going to give you some guidelines on how you're going to write the remaining part of your letter. And before I do that, remember that you must leave some space before at the start of each paragraph. Okay? Beginning of each paragraph, you leave some space. You leave a margin. So I want to give you some guidelines that you're going to use to complete this letter. So these are the guidelines or the guiding questions. The guiding questions. And remember, you are writing a letter to your friend. It says this, write a letter to your friend So write a letter to your friend about a time when you looked after a sick person. Your friend is Jane. Okay? So I'll give you the guiding questions. Number one, So these are the guiding questions. Who was the person? Remember, you're writing to Jane. We're going to tell Jane who the person was. Who was the person? What was the matter with the person? Why was this person sick? Okay? Where did the person live? 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 Number 4, why were you looking after him or her? Why were you looking after that person? Remember, Keisha looked after her grandmother because she was living alone, okay? And she was a widow. So why were you looking after that person? Next, what did you do for the person? What did you do for that person when you looked after him or her? Number 6, did the person get better? Did the person get better? And lastly, did you enjoy looking after the person? Did you enjoy looking after the person? So these are the guiding questions that you're going to answer as you write your letter here. So the second paragraph, but you can even have just 3 paragraphs, okay? The second paragraph, answer these questions. Okay? Answer these questions. Then you can answer question 5 and question 6 in the third paragraph. Third paragraph. So second paragraph. Second paragraph. Then 5. Third paragraph. Third paragraph. Now, once you are through with your major sections, we have the last paragraph, okay? What you call now the ending of the letter or the signing off. You can write something like this. I'm assuming that you have written your second paragraph here, your third paragraph here. Now the last paragraph, okay? Normally a short one. Normally a short one. So I'll write from here. I'll visit you. My dear friend, when we close school. I'll visit you, my dear friend, when we close school. Send my warm regards to your parents and siblings. And then you now skip a line and write. You write here, your loving friend. You write here, your loving friend, Aisha. Your loving friend, Aisha. Okay? So once you are through with the final paragraph, you skip a line. Then you write here, your loving friend, Aisha. So that's how we write a friendly letter. But I've said before you write this final paragraph, you should have written paragraph 2 and paragraph 3. And these are the guiding questions. All right? So my dear learner, I want you to complete this letter. We have done together paragraph 1 and paragraph 4. So this paragraph 2 here, Then there's paragraph 3, and I've said paragraph 2, you answer questions 1, 2, 3, 4 in paragraph 2. Then you go to paragraph 3, where you're going to answer questions 5, 6, and 7, okay? Then this will be a paragraph 4. So complete paragraph 2 and 3 before you write paragraph 4 and 5. And that's how we write a friendly letter. So my dear learner, today we have learned about writing a friendly letter, and you have said you write that letter to either friends or relatives. And the letter will have an address of the receiver, all right? It will also have what we call a salutation. Use words, the word dear. Then it will have a body while you're writing that letter. Then it will have an ending, all right, as I've shown here. So please practice writing letters, and once you attempt, you can even send to us your sample so that you can also mark and see if you have understood today's lesson. So until next time, my dear learner, thank you so much for being a wonderful student. God bless you, and goodbye for now.
Welcome to Manifested Publishers.
Welcome, learners. My name is Stephen Kariungi. We are continuing with our biology lesson, Form 1. And today I want us to discuss the differences between plant cells and animal cells. So we've been discussing the various structures that are found in plant cells and those that are found in animal cells. But for today, I will look at the differences. So we have the differences between one of the differences between a plant cell and an animal cell is in terms of the size, in that a plant cell is usually larger compared to the animal cell. So the animal cell is usually smaller. Another difference, the plant cell has a definite shape. An animal cell has no definite shape. So we have very many shapes. Another very fundamental difference is plant cells have chloroplasts that contain chlorophyll. And that is the chlorophyll that we said is for photosynthesis. Number 3, for animal cells have no chloroplasts. In terms of the cell wall, the plant cell have cell wall. Animal cells have no cell wall. For the plant cell, it has a large and centrally located vacuole, but the animal cell has no vacuoles, but if present, they are very small. They are small and temporary. So they don't go throughout the life of the animal. More differences. As a continuation, number 6 is in terms of the nucleus in the plant cell. The nucleus is found towards the periphery of the cell membrane. For the case of the animal cell, nucleus is centrally located at the center. Plant cells have no centrioles. Animal cells have centrioles. For the plant cells, they store starch, oils, basically the starch and oils. While animal cells they store glycogen and fats. So basically those are the differences that exist between plant cells and animal cells. In terms of the size, the plant cell is larger. The animal cell is smaller. In terms of the shape, the plant cell has a definite shape. Animal cell has no definite shape. Plant cells have chloroplasts that contain chlorophyll for photosynthesis. In animal cells, there is no chloroplasts, hence no photosynthesis. Plant cells have a cell wall. Animal cells have no cell wall. Plant cells have large and centrally located vacuole. Animal cells have no vacuoles, but if they are present, they are small and temporary. They do not last through the lifetime of the animal cell. Nucleus of a plant cell is found towards the periphery of the cell membrane, whereas the nucleus of an animal cell is centrally located at the center. 7, no centrioles in plant cells, but we have centrioles in animal cells. Plant cells store their food in form of starch and oils, whereas animal cells store glycogen and fats. So glycogen is a carbohydrate that is stored in animal cells. Starch is a carbohydrate that is stored in plant cells. In addition to that, plant cells have oils, but animal cells have fats. So basically, those are the differences that exist. So we'll have an assignment on the same. So the first question, name 3 food substances that are stored in A, animal cells, and B, plant cells. And number 2, give 2 main differences between an animal cell and a plant cell. So we'll stop there and continue next time from there. Goodbye.
Welcome to Manifested Publishers.
Hello learners and welcome back to today's lesson. We continue with the lesson in social studies. The topic is citizenship. We are studying inclusion of persons with special needs in the society. In our last lesson, we defined persons with special needs in the society, and we stated gave examples of people with special needs in the society, like those who are visually challenged, those who are mentally challenged, those who face social and economic challenges, and so on. Now, learners, all these people require help so that they can go about their daily activities. They require help. Persons with special needs should be included or be involved in various activities in the society so that their unique talents, their abilities, their interests can be taken care of and also be developed fully. All people with special needs, persons with special needs require help so that they can go about their daily activities with ease. Because they are just as human beings as the rest of the people in the society. They have needs which must be met. So persons with special needs should be included or be involved in various activities in the society so that their unique talents, their unique abilities, their unique interests can be taken care of and be developed fully. They should not be viewed as a burden, because persons with special needs have special talents. They have unique talents. Learners, by now you must have learned that every human being is talented. Every human being has unique talents. Every human being has something to offer in this world, including persons with disabilities, those who cannot see, those who cannot walk, those who cannot hear, those who are mentally challenged, those who are facing social and economic challenges, including street children, the elderly, those who are living with HIV and AIDS. All those people are talented. All those people have abilities. And what we need to do is to take care of them and to help them develop these talents, these abilities fully. Because when these talents and abilities are developed fully, then the society benefits. Learners, maybe you are listening at me and you could be one of the persons who has special needs. Maybe you cannot see, you cannot hear, you are lame, you are visually impaired, you are elderly. If you are in that category of persons, you are not less of a human being. You have unique talents. The rest of the world needs that talent. So, learners, the question now is, how do we help? How do we take care of? And how do we develop the talents, the abilities, and the interests of persons with disabilities, persons with special needs. That's the question we want to answer in our today's lesson. How can it be done? How can we help persons with special needs? One way is creating positive attitudes. One way is doing what? Creating positive attitudes. The question I'm answering is how to take care, and develop talents, abilities, and interests of persons with special needs in the society. How to take care and develop talents, abilities, interests of persons with special needs in the society. I've said one way is by creating positive attitudes. Creating positive attitudes. Now, learners, disability, we have always been told, is not inability. Persons with special needs have their own interests, they have their own talents, they have unique abilities. So a person, for example, who is visually impaired may be a great athlete because his or her legs and lungs are very healthy. Others may be visually impaired, but very intelligent. Some of them are good musicians. So learners, such people should be seen as human beings first because they think, they feel, they eat, they drink, they sleep just like any other human being. So we should encourage such people to take part in activities in the society just like other people. People with disabilities should not be discriminated against on the basis of the challenges they face. So by developing a positive attitude towards people with special needs, we are able to involve them in nation-building activities. So we need to do what? To create positive attitude. Because they should not be viewed with pity. No, they can be helped, but it should be remembered that these people are just as human as the rest of the members of the society. They are human beings, and they could be intellectually better than other people. We've seen them performing very well in their endeavors, in the areas in which they are endowed. So we should encourage such people to take part in activities in the society. They should be encouraged because some of them may not, they may feel less human, yet they are fully human. So that's very important. Creating positive attitudes. Creating what? Positive attitude. They should not be looked down upon. No. Another point, B, is creating friendly environments. Creating friendly environments. Learners, we should accept people with special needs as equal members of the society. And we show our acceptance by creating an environment in which they can live and work without difficulties. We can do this by ensuring that the places they visit, the places they work in and live in are easily accessible. For example, entrances and exits to buildings and at foot bridges, for example, should have alternative sloping ramps. This makes it easy for people on wheelchairs, those using crutches, and even the visually impaired to enter the buildings or use the foot bridges. Lifts also help the physically challenged to access different floors in buildings. And in the towns or urban centers, parking spaces should be set aside for use of people with special needs. I can also mention drainage trenches. The drainage trenches should be covered, and visual signs or symbols used to mark certain areas and facilities. We need also to have appropriate toilet facilities which should be provided for the physically challenged in the society. There should also be a requirement for public service vehicles to have wide doors and provide ramps at the entrance. This will help easy access for the physically challenged. So learners creating such friendly environments will is one way of taking care and developing talents and the interests of persons with special needs. The environment should be friendly when constructing buildings, when constructing drainage systems and all the areas that I've highlighted. The learners, the environment should be friendly. Is one that makes the life of people with disabilities easy. By doing so, we'll be accepting them as equal members of the society. And we show our acceptance by creating an environment in which they can live and work without challenges. Especially the places where they live, the places where they work, and so on. Those places should be easily accessible. So creating friendly environments is one way in which we can take care and develop the talents and the interests of persons with disabilities. C, providing equal opportunities. Providing equal opportunities. All people in the society should get equal opportunities to work and improve their lives. There should be no discrimination on the basis of disability or on the basis of diseases such as HIV and AIDS. There are people with special needs who are great scholars, great athletes, great teachers. These people have made great contributions in the society in different ways. People with special needs should be given an equal chance to go to school and learn. And in the case of certain special needs such as visual or mental or hearing impairments, such people should be taken to special schools where special learning facilities like Braille and audio tapes are provided. In Kenya, we have such schools. And learners, during national meetings, during conferences, during seminars, the different groups of people with special needs also need to be represented. This is important since this special group of people has a right to be heard. They should therefore be given an opportunity to express themselves and their interests and to actively take part in national development. Providing what? Equal opportunities. And learners, this may include information about what is happening in the country and what is required of the individual is passed on to those who cannot hear by use of sign language. And we have seen this even during television news broadcasts. It should also be remembered, learners, that the Constitution of Kenya also requires political parties to include some people with disability among those they nominate to parliament. That is one way in which equal opportunity is provided to people with special needs. So learners, that will mark the end of our today's lesson. We've answered the question, how can we take care and develop talents, abilities, and interests of persons with special needs in the society? I've explained 3 points: creating positive attitude, creating friendly environments, providing equal opportunities. So thank you for being attentive. I want you to go through the lesson one more time. Take notes. I've written short points. Below every point, write notes. Then go through the notes once more. After you have done that, I want you to answer this revision question. State 3 ways in which we can take care of the interests of persons with special needs in the society. Make sure you answer this question before you attend our next lesson. Thank you and bye-bye.
Welcome to Manifested Publishers.
Hello learners, welcome to Manifested e-learning platform. I am Teacher Purity and we are going to learn CRE grade 2. Now we are going to talk about the Bible story, the call of Samuel. The call of Samuel. It is a Bible story because it is found in the Bible. So sit back and make sure that you are concentrating. Now at the end of this lesson, I will require you to describe or talk about the call of Samuel. So the call of Samuel. Who is Samuel? Now Samuel is a man of God, and he is found in the Bible stories, and he was used by God. We want to see what happened to him and how was he called. Now most of us, we have parents at home, we have relatives and other people who are around us. Sometimes they do call us. How do you respond to a call? When you are called by a person, when your mother calls you, how are you supposed to respond? Are you just supposed to assume as if you've not heard, or you are supposed to respond and run to the person who has called you for you to know why he or she has called you? So the call of Samuel, we want to see how Samuel responded to the call and what happened. So the call of Samuel is found in the book of 1 Samuel. 1 Samuel chapter 3 verse 3 to 10. So it is found in the book of 1 Samuel chapter 3 verse 3 to 10. 1 Samuel is an example of a book found in the Old Testament. So I will read for you the story about the call of Samuel, then we shall talk about it. So I read from the Good News Bible. I'll open. So the book of Samuel, I read from 1 Samuel chapter 3 verse 3 to 10. It is talking about the call of Samuel. So the Bible says, Samuel was sleeping in the sanctuary where the sacred covenant box was. Before dawn, while the lamp was still burning, the Lord called Samuel. He answered, "Yes, sir," and ran to Eli and said, "You called me. Here and here I am." But Eli answered, "I didn't call you. Go back to bed." So Samuel went back to bed. The Lord called Samuel again. The boy did not know that it was the Lord, because the Lord had never spoken to him before. So he got up, went to Eli and said, "You called me, and here I am." But Eli answered, "My son, I didn't call you. Go back to bed." The Lord called Samuel a third time. He got up, went to Eli, and said, "You called me, and here I am." Then Eli realized that it was the Lord who was calling the boy. So he said to him, "Go back to bed, and if he calls you again, say, 'Speak, Lord, your servant is listening.'" So Samuel went back to bed. The Lord came and stood there and called as he had before, "Samuel, Samuel." Samuel answered, "Speak, your servant is listening." Now the book of 1 Samuel chapter 3 verse 3 to 10 is telling us about the call of Samuel, how Samuel was called. So from what we have read in the Bible, we see that Samuel was living in a temple with the priest Eli. He was staying in the temple with priest Eli. And while he was there, that is when the Lord called him. So Samuel was living in the temple with priest Eli. Let's note that. Samuel lived in a temple with priest Eli. So Samuel lived in a temple with the priest Eli. His parents took him to the temple and he used to live with priest Eli. A temple is a place where you go and worship God. So while Samuel was at the temple, the Lord called him. The Lord called Samuel 4 times. And from the story in the Bible, we see that the first, second, and third time, Samuel was responding yes, but he thought that it was priest Eli calling him. So he was waking up from his sleep and running to priest Eli, telling him, "You called me." And priest Eli will say, "No, I didn't call you. Just go back to sleep." So it happened 3 times. But the third time, priest Eli realized that it was God who was calling Samuel. So he told Samuel what to do. He told him, when you are called, when you go back and sleep, then you are called again. Make sure that you are responding and you say, "Speak, my Lord, your servant is listening." So Samuel obeyed what priest Eli had told him. He went back to his sleep, and the same voice called him again, but this time round he responded and said that, "Speak to me, my Lord, your servant is listening." So what does that tell us? It tells us that Samuel was called 4 times. So Samuel was called 4 times. Samuel was called 4 times. Samuel was called 4 times. And in the 4 times he was called, the 3 times he was running to priest Eli, thinking that priest Eli was the one calling him. So 3 times Samuel thought that it was priest Eli calling him. So 3 times Samuel thought it was priest Eli calling him. So remember that Samuel was called 4 times, but the first 3 times Samuel was waking up from his sleep and running to priest Eli's room, thinking that priest Eli was the one calling him. But the third time priest Eli realized that it was the voice of God which was calling Samuel. So he told Samuel the fourth time when he'll be called, he should respond. So Samuel responded the 4th time. Samuel responded to God. Responded to God's voice or to God's call. The 4th time. So Samuel responded to God's call the 4th time, and he obeyed God. Samuel obeyed God's call and said that he was ready to do what God will instruct him to. So Samuel obeyed God's call. Samuel obeyed God's call. Samuel obeyed God's call. He was ready to do what God wanted him to do. So he was ready. He was ready to do what God wanted him to do. So he was ready to do what God wanted him to do. So after Samuel responded to God's call by saying, "Speak, your servant is listening," it meant that he was ready to do whatever thing that God will have asked him to do. That one tells us we are supposed to obey God. How do we obey God? By following the 10 commandments. God gave us the 10 commandments. When you follow the you follow the 10 commandments, it means that you are obeying God. When you obey your elders, when you listen to what other people are telling you, as long as it is something that is good, that means that you are obeying God. So this is all about the call of Samuel. Samuel lived in a temple with priest Eli. He used to live in a temple with a priest called Eli. And Samuel was called 4 times. He was called 4 times by God. But 3 times Samuel thought it was priest Eli calling him. That is why the first, second, and third time he was running to priest Eli's room and asking him if he is the one who called him. But the 4th time, priest Eli realized that it was God who was calling Samuel. So he advised Samuel to go back to sleep. But when he is called again, he should respond and say, "Speak, your servant is listening." So Samuel went back to sleep, and the voice called him again, and he responded. So Samuel responded to God's call the 4th time. He responded to God's call the 4th time. And Samuel obeyed God's call. How did he obey God's call? When God called him, he responded. That tells us that when you are being called by your parent or any other person, you are supposed to respond. In fact, when you are at a far distance from whoever is calling you, you should run to that person and listen to what he or she wants to tell you. So Samuel obeyed God's call, and he was ready to do what God wanted him to do. Samuel was ready to do what God wanted him to do. And from the story of Samuel, we learn to be obedient. We are supposed to be obedient. Respect. You respect your elders. Respect your parents. Respect your teachers. Respect your classmates. You are also supposed to respect your schoolmate. So that is all about the call of Samuel. I'll leave you with some work to do. You copy the questions and make sure that you are answering them. In our next lesson, we shall be talking about something different. It will still be about a Bible story, but a different story, not be Samuel. We shall talk about another story from the Bible. So the assignment is here. Now you have 4 questions, and the answers are provided in the brackets. So when you are reading the question, make sure you are also reading the answers in the brackets before you choose the correct answer. Now the first question, Samuel lived in a dash. Samuel lived in a dash. The answers in brackets: church, temple, house. Question 2, Samuel lived with priests dash. Eli, Elikana. You'll select the correct answer. Number 3, God called Samuel dash times. 4, 2, 3. God called Samuel dash times. 4, 2, 3. Choose the correct answer. And lastly, the story of Samuel teaches us to be dash. From the story of Samuel, what do we learn? Teaches us to be dash, kind, obedient, honest. So you'll select the correct answer and fill in the blank space. Hope to see you in the next lesson.
Welcome to Manifested Publishers.
Welcome, learners. My name is Stephen Kariungi, and today we continue with our topic of discussion, nitrogen and its compounds. So we have already discussed the laboratory preparation of nitrogen gas and the properties of nitrogen gas. So I'd like us to briefly look at the uses of nitrogen. And first of all, nitrogen is used in the large scale manufacture of ammonia. And this process, we refer to it as Haber process. So during Haber process. So Haber process is the process that is involved in the large-scale manufacture of ammonia, and nitrogen is used as one of the raw materials. 2, nitrogen is used in light bulbs. The bulbs that we commonly use, due to its inert nature. It is inert. It doesn't oxidize the filaments of the bulb. So because of the inert nature of nitrogen gas, it is used in light bulbs due to its inert nature. It's relatively inert that prevents oxidation of the filament. Oxidation of the filament. And 3, nitrogen, because of its low boiling point, it is used as a refrigerant. As a refrigerant due to its low boiling point, very low boiling point is used, and this is especially in the storage of semen, for artificial insemination. So the storage of semen for artificial insemination requires very low temperature, and those very low temperature can be provided by liquid or liquefied nitrogen, which has a very low boiling point. So having discussed about nitrogen, its preparation, properties, and uses, we are going to next discuss the oxides of nitrogen. And basically, nitrogen has 3 common oxides. Number 1, we have what is called nitrogen 1 oxide. So these are now the compounds of nitrogen. These are not now pure nitrogen, but they are nitrogen compounds. They are nitrogen oxides. So we have nitrogen 1 oxide, which is written, whose formula is that. We also have nitrogen 2 oxide, whose formula is indicated there. And then we have nitrogen 4 oxide. So basically those are the oxides of nitrogen that we have, compounds of nitrogen and oxygen. So we'll start with the first one, and this is nitrogen 1 oxide. This nitrogen 1 oxide, in its preparation, it is prepared in the laboratory by heating ammonium nitrate. In Form 2, under the topic of salts, there's a place where we learnt about action of heat on nitrates. And we saw that ammonium nitrate, as one of the nitrates, decomposes on heating, what we call thermodecomposition, to form nitrogen 1 oxide. So you can see that nitrogen 1 oxide is prepared in the laboratory by heating ammonium nitrate to decomposition. Ammonium nitrate to decomposition. So we are saying that ammonium nitrate, it undergoes thermodecomposition to produce nitrogen 1 oxide plus water. Nitrogen 1 oxide is a gas. So if we balance, those are 4 hydrogens and 3 oxygen, 1 plus 2. And that equation is balanced. And then we can say that nitrogen 1 oxide is collected over warm water. Is collected over warm water because it is soluble in cold water. So once we have prepared the gas, nitrogen 1 oxide, we are supposed to collect it over warm water. And that is the reason that it is soluble in cold water. So if you use cold water, you may not collect much gas. So let's see the diagram that is involved in the preparation of nitrogen 1 oxide. So we have heat. We heat ammonium nitrate. Then it's collected over warm water because we said that the gas is soluble in cold water. Then we have nitrogen 1 oxide. So this is the laboratory preparation of nitrogen 1 oxide. So we should put the flask in a slanting position to make sure that the water that is produced does not flow back into the hot flask. Because if it flows back into the hot flask, it would break or it would cause cracking of the flask. So basically it is important that we place the flask in a slanting position so that the water that is produced does not flow back. So we are going to have an assignment on nitrogen 1 oxide. the assignment, explain how nitrogen 1 oxide is prepared in the laboratory. 2, write an equation for the reaction. And 3, explain why the flask is placed in a slanting position during preparation. During preparation. So we'll stop there. Until next time, goodbye.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi, and we continue with our topic of discussion, a topic in Form 2 chemistry, and this is structure and bonding. Now, we are going to see the various ways of illustrating ionic bonds. And during our last lesson, we saw an example of how to illustrate by use of a dot and cross diagram the structure of sodium chloride. So today, we are going to illustrate formation of magnesium fluoride. So magnesium fluoride is also an ionic compound because magnesium is a metal and therefore it forms a positively charged ion. Fluorine is a non-metal and therefore forms a negatively charged ion.